All right, so I'm Linda Nichols. I'm Lina Lou on the internet, just about everywhere. Twitter, GitHub. I'm not Lina Lou on Snapchat. I was too late for an account, so I'm something else, Lina Lou 123 or something. Yeah, so I founded and organized Norfolk JS and NodeBots Norfolk. It's happening at the end of July if anyone likes robots, JavaScript, and lots of kids. I also organized RevolutionConf, founded and organized just this past June 1st and 2nd, and it's happening again next year, like mid-May. And I work for Emerging Technology Advisors. I work with the greatest group of people, most of whom are here in Reston, Virginia. And yeah, one of my coworkers is here now, maybe some more later. Feel free to come talk to us about what we do. But for right now, I'm here to talk about the monolith. And when we think of monoliths, we think of this, right? It's granite, it's strong, it's going to weather the storm, it's going to last forever, and it's worshipped by apes. But also there's the monolithic application, which is single-tiered, is responsible for performing all the tasks of your application. It's not very modular. Everything is contained inside of this monolith. It's like usually has some legacy technology, and it's either running on premises on your servers or it's on a mainframe, it's hosted somewhere. And it's almost certainly expensive to host. It's a very big system. So here's a diagram of maybe a monolith with all of the tiers contained inside. And it's doing all the things. Looks kind of like a little Mike and Ike. So based on that description, like, is this really accurate? Is it really a monolith? Is it gonna last forever? Is it strong? I mean, the only thing that this depiction has in common with your monolithic application is that it's expensive and it's possibly this old. It might have predated man. So I would say that it's a little bit more like an onion. Because it's perishable. All the layers are contained inside. It really sucks to cut up into pieces. And yeah, if you install your monolithic application directly on a mainframe, or you put an onion on a mainframe, it's the same kind of mess. Like, good luck getting that thing out of there. And it's kind of smelly. So, like, the next time you talk about a monolithic application, like, good luck now not thinking about cutting up an onion. So what we want to do with our monolith is we want to break it apart. We want to separate out the tiers. We don't want our client or server data access everything in this one little Mike and Ike diagram. We want to upgrade the technology. We're thinking about modernization. We want to rewrite the code. I mean, maybe this is COBOL, maybe it's Java, maybe we want to upgrade to something that's a little more efficient. Maybe we want to use multiple languages. Maybe we want JavaScript in the client, and we want Go on the back end, or Rust, or whatever. And we want to move it to the cloud, whatever the cloud means to you. Maybe it's one of the 4 main cloud providers, IBM, Microsoft, Google, Amazon. But that's a great list, but it's really expensive. And your team now is working on your monolithic application. They're writing in that language. They're working with that technology. And now they're expected to help break it apart into microservices and upgrade it and maybe rewrite it. Well, maybe they don't have the skills. So we're looking at paying for training for them. We're looking at hiring contractors. And all this is very expensive. So because of that, legacy just stays legacy. It's good as it is. My team can patch it. They have the skills. Something kind of breaks. We put a Band-Aid on it. And we keep going. And for now, we're paying a lot of hosting fees. It's expensive to just exist out on a mainframe or a hosted server, but we're just going to keep it as it is because our developers are happy, and we'll just worry about a failure when it comes. So another option is that we throw this onion in a container, and we sort of we contain that smell, and we get to now put it up in the cloud a lot easier. It's a lot easier to deploy. It's more secure, scalable. This is a great solution. But the problem is that we still have to break up that monolith. I mean, we can containerize the entire thing, but ultimately we've still got to cut up that onion and put it into multiple containers to really get the benefits of a containerized environment. And also, this can now be expensive too, because your development team doesn't know containers. They're not DevOps people. So they may be able to break up the application, but they don't really know how to containerize and deploy. There's more training expense. So we're going to go a little bit deeper. What do we do? So now we're going to talk about serverless a little bit. So serverless has been around since, like the idea of serverless architecture has been around since like late 2014, but it's still considered like the hot new thing, the cool new thing. So whenever you talk about serverless architecture, you have to start out with this what is serverless slide, because like still, even people like me that are talking about it a lot, still don't really know. So I kind of came up with this definition that kind of is sort of the best description for right now. But I also have to start out and say, this is a terrible name because there are servers. But you don't have to care about them. So that's why they're serverless, because we can now push them out of our minds. And so the special thing, the revolutionary thing about serverless architecture is that it's event-driven. And that's important because there's a lot of focus on the back-end as a service, the function as a service, AWS Lambda, but really the thing that makes it most special is the fact that it's driven by events. And I'll talk about that a little bit. So a back-end as a service is going to be like PubNub, Firebase. Your function as a service is going to be OpenWhisk. It's going to be Lambda. And I'm going to kind of talk about Lambda sort of as in most of my examples. So when I'm talking about Lambda or other serverless functions, the main thing is that I don't need to know DevOps. I don't have to care about DevOps. There are containers. Containers are awesome, and they're there, but I don't have to know anything about them. That's Amazon's job. That's Microsoft's job. On the development team, my developers, they only focus on code. And they can focus on code that they've already written. If they've written a Java application, they can cut and paste existing code into these serverless functions. They're going to have to learn some new skills, yes, but they don't have to learn a completely different architecture. They're still really focused on their existing monolithic application, but they're just taking pieces and putting it into these functions. And they're triggered by internal, external events. So for instance, if your monolithic application has an event bus, you can take those events from your event bus and send them up to AWS, and then those can trigger Lambdas. Or HTTP events. You can send an HTTP event from your monolithic application up to AWS. It can trigger Lambda. And sort of speaking of those events, there's a built-in API gateway in all of the main sort of function as a service offerings. So if I'm making a Node.js application, I don't have to worry about Express. I don't have to worry about Happy. I don't need an HTTP server. I just use this API gateway. And I build all of my routes within AWS in the cloud. So I'm still worried about only back-end code, about just the functions themselves. And then those events are going to call my functions. But the really, really cool thing is that this doesn't cost anything. Like I only pay when I invoke one of my functions that I've written. And I can hit these functions like 1,000,000 times and I'm only paying pennies. And so some of the bigger companies that are sort of early adopters of functions as a service are like Netflix. And the story is that when Netflix started breaking out their system into microservices and then pushing those microservices to Lambdas, that 6 months went by and they didn't pay anything. And they're used to a big bill. So yeah, there's not a lot of risk because there's not a lot of money. So this is kind of what a serverless function would look like if you're writing Node.js. It has one very specific function, and that's to give me a random cat name. And this is it. It does one thing. And it's not just really even a microservice, it's like a nano service because it does so little. And that's how small that these services can be. So they're doing one very small task. They're lightweight, they're fast, they're reusable. These are all sort of the definitions of microservices in these functions as a service. They're stateless. Every time you invoke this function, it rebuilds your container. So you start from scratch every single time. And it's not dependent on anything else. In your monolithic application, everything is sort of dependent on everything else. These functions are completely independent, and they're invoked by events. So let's talk about peeling the onion. We're going to break apart our monolith, but we're going to do it very gently. We're not going to crush it. We're not going to cut it up. We're just going to sort of peel away the layers in a very gentle fashion. So what we're going to do first is we're going to look at our monolithic application, and we're going to care a lot about cost, and we're going to care a lot about risk, because rewriting your whole application is very risky. I mean, even if you're prepared to pay all the money, if you're prepared to bring in the contractors, if you're prepared to train your team, you could rewrite the whole thing, and you could save no money and not get anything out of it. By peeling off a layer and trying it out, then you've got a proof of concept that's very cheap. So you can look through your monolith and say, okay, what are the sorts of things that I can pull off that would be easy to roll into a Lambda? And so cron jobs, because scheduled events is something that can trigger a Lambda. Background services, your workers, those are things you might be able to pull out. Calls to APIs, because you can set up your Lambda functions, put an API gateway in front of them, and then you can call those APIs from inside of your monolithic application. Any external API calls you're doing now, any calls to direct calls to evoke functions, you can make those now APIs. Logging and analytics. Take anything about logging, send it up to Amazon. Let Amazon do what it does best. It can give you tons of information about how your system is running. So let it do the work. And finally, anything that's on a message bus. If you are putting data into your database and you send that information up to an enterprise service bus that's circulating around your Mike and Ike, send those events up to Amazon. Trigger Lambdas. And so, yeah, this is like a real picture of me now peeling that onion and making tons of Lambdas, because that's how quick it is to make Lambda functions. It's very fast. So yeah, in conclusion, as I'm peeling away the onion, every time I take away a layer, that onion is lighter. And it's less compute power, and it's costing me less money on this mainframe or on premises or wherever I'm hosting this thing. It gets slightly cheaper. And it's now more manageable. It's now less expensive. There's now a core of an onion left after I've peeled away all these layers, and that core is now so small that it's a little bit more manageable for me to cut up to turn into modules. Just to kind of wrap everything up, serverless architecture it helps me peel away these layers to try things out, not take a lot of risk. Things are less expensive. And if you're a company that's looking to modernize your monolithic application, it's really kind of scary to bring in a whole team of contractors and pay several $100,000 to break up this application that your team has been writing for years. So we get to keep your team totally involved. It's their code. We'll put their code out into Lambdas, and they're heavily involved. And you can still bring in contractors, like me, and I will help your team to break apart their code. But I don't think that it all has to happen at once. I don't think we have to smash up the onion. We don't have to cut it up. It's really scary. So yeah, peel away your onion, and good luck thinking of a monolith as a monolith again. All right, thank you.